Hi everyone and welcome to my channel. I'm Eugene and this channel is dedicated to teaching of programming and software development. Until now, we were dealing with simple programs that were using variables and methods that performed tasks on their input to produce some output. In this lesson, we will start learning a new concept named object-oriented programming. This is actually a different approach to programming that requires different thinking of how the program is designed. It's a very big topic, and a separate course can be created only about object-oriented programming. So in this lesson, we are not going to cover everything related to OOP. This will be more of an introduction, but we will learn the basic ideas so you will be able to work with OOP after this lesson. As we saw before, when working with variables and methods separately, the data we work with is separated from the operations we can do with that data. The general idea of OOP is to combine the data and the operations related to that data together into a single entity. Object-oriented programming is a programming approach where a program is built from objects that combine data and behavior into a single unit. With this approach, we look at entities in programming in a similar way to how we look at objects in real life. For example, if we look at a car in real life, we know that it has its properties like model, color, as well as some other technical specs, but it also has some functionality like acceleration, stopping, turning left or right, turning on the lights, and so on. Also, in real life, we can have many cars of the same model with exactly the same specs. They are all produced based on the same design of a car, but there are many copies of that car. Once the car is produced, every car has its own life. The cars are working independently of each other. In object-oriented programming, the idea is the same. We first design what data and operations the objects will have, and then we create objects based on that design. For example, consider that we want to write a program that has cars with their properties like brand, speed, number of seats, maximal speed, and so on. Also, we want to be able to perform some operations on those cars like accelerate or brake. How would we do it using the knowledge we have so far? We would probably create variables named car brand, car speed, car seats, car max speed, and so on. Pay attention that we would need a copy of those variables for every new car that we create. Then if we want the car to accelerate, we would write a method that gets the speed and adds a number to it. And our program would probably look like this. Now, as the program gets bigger, it becomes very inconvenient to maintain the code. So we need a way to organize our cars into self-contained units. This is where object-oriented programming, or OOP, comes into play. Instead of defining variables for the properties of the cars and separately defining the methods that work on those variables, we want to create an object that will contain the required data and behavior together. To unify the data and behavior, we are going to create a new type, or more precisely, a class. You can think of a class as a blueprint that describes what an object looks like and what it can do. A class is not a real object. It's more like int or string. It only defines what the variable can hold and what operations can be performed with that object. So a class is the definition of the new type that has its fields and has methods that can be run on this type. If we go back to our car example, a class named car would look like this. As you can see, a class is defined using the class keyword followed by the class name. Then we are creating a block using curly braces in which we define what the class contains. Now, once we have the class defined, we still don't have any car. The class, as we already said, only defines how a car object will look like. So we need to create an actual car based on the car class. To do this, we would create an instance of the car class like this. As you can see, we define a variable of type car and assign an object of that type created using the new keyword. To do this, we would create an instance of the car class like this. As you can see, we define a variable of type car and assign an object of that type created using the new keyword. Then we can change the values of the fields of my car, like setting its max speed, for example. We can access the fields of the object using a dot after the object name. After the dot, we can type the name of the field, like max speed. Also, we can run the accelerate method on that object. This is also done by adding a dot after the object's name and then the name of the method. And we can create as many objects like this as we want. They will all have the same structure and operations because they are all based on the car class. But every object will have separate values, and they will be all independent of each other. Changing the values of the myCar object, like max speed, will change only this specific object. These changes have no effect on the other objects created from that class. So to define an object, we can say that an object is a real instance created based on a class. As you can see in the example, an object is created with the new keyword followed by the name of the class and then parentheses. This creates an object of this class in memory. Once the object is created in memory, we assign it to a variable of the class type to be able to reference it later. In our case, we create an object of type car and then assign it to the myCar variable of type car. To summarize, car is a class that defines how objects of that class will look like, while myCar is an object created based on the car class. As we already said, a class defines what data the objects created from the class will have. The data is defined by declaring fields inside the class. Fields are declared almost the same as we declare variables, with some differences that are specific to classes. The most basic syntax is this: public string brand. If we skip the public keyword, then we first state the type of the field and then the field name, just like any variable or parameter definition. We'll talk about access modifiers later, but for now, public means that the field is directly accessible to the users of the object and not only to the object itself. Now, just like with variables, we can initialize fields immediately when we declare them. In addition to data, a class can contain methods that can work with the fields of the class. A method is declared just as we already know, with some additions related to the fact that they are defined within a class. For example, the public keyword means that the method can be called by the object's users and is not internal to the class. Pay attention that inside the method, we can access any field defined in the class. And we work with the fields of the specific object that we run the method on. For example, if we have two objects of the class car, and we call a method named accelerate on car1, then it will change the speed of car1, but car2 will remain as it was before. Now, you've seen already that to create an object, we use the new keyword, and then the name of the class and parentheses. This creates an object of type car. When an object is created, a special method in the class is executed, and this method is responsible for the initialization of the object. This specific method is the constructor of the class. A constructor is a special class member that initializes an object when it is created. For example, in our car class, we could have a constructor like this. Pay attention that a constructor has no return value. However, like other methods, it can get input parameters, and we can use them inside the constructor to initialize the object. For example, we could set the number of seats in the car when the object is created. Then when we create the object, we will need to provide the number of seats as an argument to the constructor, as you can see on the screen. Now, if the constructor gets some input parameters, we must provide them when creating the object. This is usually done to enforce initialization of members with values provided by the user of the class. Just like in our case, we can't create a car until we know how many seats it should have. Notice that we can have multiple constructors, just as we can have multiple methods with the same name. If we look at the constructor that we've seen before, you may notice that we have the parameter number of seats and the class field named car seats. In our case, they have different names, so when we write number of seats, C# knows we mean the parameter, and when we write car seats, it knows we refer to the class field. But what if both the class field and the parameter of the constructor, or any other method, have the same name? What if our field was named number of seats, just like the parameter? How can we differentiate between the two names? The solution is simple. We can use the this keyword. This is a reference to the current object, which means everything we access using the this keyword is a member of the class. So we can write this, then dot, and then any member of the class, and it will belong to the current object. In our case, the constructor would look like this. When we say this dot number of seats, we refer to the field, and when it's just number of seats, it's the parameter. Pay attention that we can use the this keyword whenever we want to use a member of the current object, even without the need to distinguish between a parameter and a field. Now, let's talk about access modifiers and why we need them. Consider that we have a car, and anyone using that car can set the speed of the car to any value. This way, we have no control over the value that the user of the class can set. For example, the user could set the speed to 200 while the maximal speed is 90. We would like to prevent from setting the speed field to any value. We want to check if the speed that the user sets is lower than the maximal speed of the car. Also, we may want to have some internal data that users don't need to access. To do this, we can define a field with a private access modifier. Now, fields and methods that are defined as private cannot be accessed from outside of the class. This means that the line of code that sets the speed won't work. It just doesn't compile. In this case, how can we set the speed field? We can define a method with an access modifier of public that will be accessible from outside, and this field can run some logic before setting the value to the speed variable, and since the method is inside the class, it can access the speed variable. So, access modifiers define who is allowed to access a class or its members, fields, properties, and methods. Access modifiers help protect our code. They prevent accidental misuse and make sure that objects are used only in the way we intend. Pay attention that we can define a method as private just as we define fields. This way, we can create methods that can be called only from within the class and not from outside. Now, as you might have guessed, protecting fields from unwanted values is a very common practice. So, C# has a special type of member to accomplish this task. Instead of writing a method of set and a method of get, We can create a property that will look like a field from outside of the class, but internally will run some logic before setting or getting the value. Consider that we have a private field of speed as before. To write a property that will expose the access to this field, we can do it like this. As you can see, we have a get clause. It will be used when we access the speed property to read its value. The set clause is used when we are setting the value of the property. Notice that the keyword value is the parameter that we provide from outside to set the value. As you can see, the usage of the property is just as if it was a field. Now, we can also set different access modifiers for the getter and the setter by specifying it before get or set, as you can see on the screen. To summarize, the idea of properties is that they should serve as a public interface, while fields are the internal storage. Now, writing properties, as we've just seen, can be repetitive and inconvenient. So there is another feature in C# named automatic properties that does just what we did, but provides a convenient syntax for the programmer. Instead of defining a field and then a property with a setter and a getter, we can simply define a property like this. We declare it with an empty get and set, and this way, behind the scenes, C# will define a private field just as we did, as well as a getter and a setter. Notice that if we want to have a custom logic in the getter or the setter, we'll need to use the previous syntax with an explicit definition of a field, because this syntax creates a default getter and setter without any validations. Also, if we want to apply a different access modifier to the getter or the setter, we can do it by adding the access modifier before the get or the set keyword. Usually, when we work with classes, we want the objects to be independent of each other. But sometimes we need some shared data between all the objects. One of the ways to accomplish this is to use static members. Static members belong to the class itself and not to any specific object created from that class. They are shared between all objects, which means that all objects will have access to the static member and will be able to get the same value. Moreover, a static member even exists if there are no objects at all. For example, we can create a static field of cars count in the car class and increase it every time a car is created. Notice that we can create not only static fields but also static methods and properties. Also, static members can be public or private, which means they can be accessible from outside of the class or only from inside. Now, let's go to VS Code and see an example of a class and its usage. Alright, now let's begin with creating a simple car class. We are creating a class and 3 fields inside. Alright, now that we have a class with 3 fields, let's see how we can use that class. Alright, so as we said, we define a variable of the type car. And we use the new keyword to create the new object. Now we can set values to the fields of this object. For example, we'll set the max speed to 90 and speed to 60. As you can see, we just created a simple class with 3 fields, and then after creating an object of that class, we can access its fields. Pay attention that we can set these fields to any value because they are public and accessible from outside, and there are no protections to anything. Now let's add a few methods to this class. Let's begin with adding a method of accelerate by that will receive the speed to add. So let's begin with defining the method. All right, now what this method should do, it should take the current speed of the car and add the provided speed. Now, the first thing that we would like to do is, of course, to check if the speed after adding the given speed is not going to be higher than the max speed of the car. So we should do something like this. Let's define a variable of final speed, which will be the speed of the car right now, plus the speed that we just received. Pay attention that using the this keyword, we can differentiate it between the speed of the car object and the speed that we just received. All right. So after adding it, what we need to do, we need to set the final speed to the max speed of the object. But first we need to check if it's not higher than the max speed. So we are going to do it like this. If final speed is higher than this max speed, we are going to print a message saying cannot add speed to the current speed because it will be higher than the max speed of the car. Now let's see. All right. And after we print this, we need, no, not after we print this, we'll just add an else clause in which we are going just to set the speed if everything is okay. This speed equals this final, just final speed. All right, now we've written a method that will add speed to the current speed of the car if it's not higher, if the result speed is not higher than the max speed. All right, let's try it. Car 1, accelerate by. So first let's accelerate by 10 and see what's happening. But in order to see that something actually happened, let's print something here. Console write line. All right, let's run it. All right, and as you can see, the speed was set to 70 is printed. Now, let's try to add even more. For example, after adding 10, let's add 30. And we'll see what's happening. All right, as you can see, we have two messages. The first one is the speed was set to 70, and the second one says that we can't add 30 to the current speed. All right, now let's just write another method that stops the car. This time it will be a simpler method, but still, let's write it just to practice. Public void stop, and this time the method doesn't get any parameters, and the only thing it does is just sets the speed to 0. And let's print a message saying the car is stopped. Okay, let's try it. Okay, let's run. And as you can see, we have the previous two messages and then the car is stopped. Now, as we already saw before, the fields are currently defined as public, which means that they are accessible from outside. So we can use the speed field just like this. Just as we set it to 60, we can set it to any number, which means that we can do something like this. Car1 dot speed equals 120. And as you can see, there is no error here, and it will even run and everything will be okay. So we would like to prevent from this situation to happen. And how we can do it? We can create a property that will validate that the speed we are setting here is not higher than max speed. So the first thing we want to do is to make the speed private. Now, as you can see, we can't set speed anymore. So right now we have no way to set the speed of the car. Right, we can use accelerate by, but consider that we want to just to set the speed, not to accelerate by a number. So to allow this, we need to do the following. We need to define a property that will expose the speed of the car, but with some protections. All right, and this property will be defined as public to be accessible from outside. Pay attention that properties are defined with a capital letter, in contrary to fields. All right, so first we are going to define a get clause. which will just return the speed. And also, we are going to define a set clause. Now, in the set clause, there is something interesting. When we defined a method of accelerate by, we received the speed as a parameter here. But as you can see, the set clause does not receive any parameter. It has no parenthesis here or something. So there is a keyword named value, which is by definition the parameter sent to this setter. So we can do the following. We can do just this, speed equals value. But first, we'll need to check if value is not higher than max speed. All right. If value is higher than this max speed, let's print a message. All right, and if everything is okay, we are going to actually set the speed. Okay, now let's try setting the speed and let's see what's happening. First, we are going to change this to the speed property, and as you can see, except for the name of the name of the property that starts with a capital letter, the usage is the same. Here we are going to change it as well. And now let's run this and see what's happening. Okay, and as you can see, we get a message, cannot set speed, 120 is higher than 90. All right, now just to show you that we can have different values for different cars, let's create another car. Car2, new car. And this time, car2 will have, first it will set its max speed that we need to set this way for now. All right, for example, 120, and car2 speed equals, for example, 30. And now let's print the speeds of those two cars. All right, and let's run it. As you can see, the cars have different speeds, which means that they are independent of each other. Every car has its own speed. Now, as you can see, we have to set manually the max speed of the car every time we create it, and even worse, we can change it anytime. So what we would like to do, we would like to initialize the max speed when we are creating the car object. To do this, let's add a constructor to the car class. Public car, and the constructor will receive the max speed. All right. Also, we will change the access modifier of the max speed field to private, because we don't want anybody from outside to be able to change it. Okay, now of course we will need first to provide the argument of max speed when we are creating the car. In this case it was 90, in this case it was 120, and we need to delete this line that sets the max speed. All right, and now if we run this, we will actually see absolutely the same. Now, what if we want to read the max speed of the car, but we don't want to be able to set it from outside? So for this, we can create a property. But pay attention that max speed has no validations when setting its value. So we can simply create an automatic property. So instead of defining the max speed like this, we can simply convert it into an automatic property. Public int max speed, and then we will set a getter that is going to be public. The getter will have the access modifier of the property, but the setter will be private because we don't want anybody from outside to change the max speed. Okay, now we have a property of max speed. Let's move it here. All right, and now we can change it here as well because we have no such field. So we are going to change it to max speed like this. And here we need to change it to max speed with a capital letter here as well. And here as well. All right. And now let's print the max speed. Let's copy these two lines. Max speed. Okay, and let's run it. Yeah, and as you can see, we have the max speed printed, while if we try to set the max speed, you will see that we can't do it. Max speed, for example, we want to set it to 200. You will see that it doesn't compile and we get an error. The property or indexer car max speed cannot be used in this context because the set accessor is inaccessible. Yeah, it's simply private. All right. Now, the last thing that I want to do is to count the number of cars created of this class. So to do this, let's define a static field that will count the number of cars created. Cars count, and we are going to initialize it to 0. Now, what we can do is whenever a car is created, we need to increase this variable. Sorry, this field. And how we can do it? Simply, we can do it like this. in the constructor of the car class, we can just write cars count plus plus. Now, what's going to happen is that every time a car is created, the cars count will be increased by 1. Now, let's write a method that will retrieve this cars count. Okay. Now, we want the method to be public because we want to be able to get it from outside. And since the field cars count is static, which means that it doesn't belong to any object, it belongs to the class, we need a method that will also be static to be able to read this field. So we define it as public static int get number of cars. And it will return cars count. Now, if we go and get it, you will see that we can print the number of cars. Int number of cars. And this time to call the static method, we need to use the class car get number of cars, and now we can print it. Okay, now let's run it and see what's happening. Alright, as you can see, the number of cars is 2 is printed, which is correct. Alright, so this was an introduction to object-oriented programming. As I said, this is a very large topic that can't be covered in a single lesson. Since this course is aimed at beginners, I tried to give you the basic ideas of object-oriented programming, but OOP is a lot more than that. This is also the last lesson of this course, so thank you very much for watching, and see you in the next course.